In this video, we're going to see how to set up a simple water treatment plant using Factory I/O. Factory I/O is a 3D simulation software designed for learning and testing industrial automation systems. It allows us to create and simulate real-world automation scenarios, such as conveyor systems, sorting mechanisms, and robotic arms. Some key features of Factory I/O include 3D simulation, allowing us to design and visualize automation processes. PLC integration, with support for major brands like Siemens, Allen Bradley, and Mitsubishi. Virtual sensors and actuators, simulating real industrial components such as sensors, motors, and buttons. SCADA and IoT compatibility, making it possible to integrate with SCADA systems and IoT devices. You can download Factory I/O from the official website. Although it is a paid software, there is a 30-day free trial available. Factory I/O allows us to build and edit industrial automation setups, making it a perfect tool for simulating a water treatment plant. For this setup, we'll be using Control I/O as our controller. Control I/O is a soft PLC designed exclusively for Factory I/O. It provides a brand-independent and easy-to-use interface, ideal for beginners in industrial automation. With Control I/O, we can develop programs using function block diagrams, similar to real-world PLC programming. Let's go through the key logic blocks we will be using for our water tank system. Tank level meter. This continuously monitors the water level. Numerical constants. These define the high and low level thresholds. Logical functions. These check if the water level is below the low limit or above the high limit. Set-reset switches. These ensure that only one state is active at a time, meaning the fill valve remains on until the water level reaches the high threshold. Assignment blocks. These assign values to the fill and discharge valves. Valve outputs. These control the opening and closing of the valves based on the current water level. Now, let's move to Factory I/O and set up this scenario step by step. Now that we have installed Factory I/O, let's begin setting up our water treatment simulation step by step. First, let's open the software. Double-click the Factory I/O icon. A welcome screen will appear. Click on the back icon to enter the main window. Now, click on File in the main menu bar and select Open Scene. Click on Scenes and you'll see a list of sample scenarios. Since we are setting up a filling tank, let's select scene number 3. The filling tank assembly will now open in the main canvas. You can move around the tank to view it from different angles. Now, we need to attach a PLC to control the system. Click on the file in the main menu bar and select Drivers. The Drivers window will open where we can select a PLC. We will use Control I/O, which is an inbuilt soft PLC. Select Control I/O, and you'll see its modules appear on the left side of the screen. We can make the controller window transparent by clicking on the eye icon on the right side. Before we start programming the logic, let's make a small configuration change. By default, the tank's input is digital, but we need to switch it to analog. To do this, right-click on the filling tank. Change the input type to analog. Now, we're ready to set up our PLC logic. Now, let's define our logic blocks. First, click on the flow meter module from the tags group. We need 2 numerical reference inputs, one for the lower limit and one for the upper limit of water level. From the Sources group, add 2 numerical modules to the workspace. Click on each module and set the maximum value to 10. Now, assign the lower reference block a value of 2. Assign the upper reference block a value of 8. At this point, we have our basic level measurement system in place. Now, let's set up the logic for controlling the water flow. First, go to the Relational Equality section. Load a less than or equal to block. Similarly, load a greater than or equal to block. Now, let's connect these blocks to our existing setup. Connect the flow meter output to input 1 of both logical blocks. Connect the lower threshold output to input 2 of the less than or equal to block. Connect the higher threshold output to input 2 of the more than or equal to block. Now we have the basic logic in place. The less than or equal to block will output true when the water level is less than or equal to 2, signaling that the fill valve should open. The more than or equal to block will output true when the water level is greater than or equal to 8, signaling that the drain valve should open. Next, we need to introduce set-reset SR blocks from the logical group. The SR block acts as a latch, meaning it remembers its state until explicitly changed. It has 2 main inputs. set activates the output Q and keeps it on until the reset input R is triggered. reset deactivates the output Q and keeps it off until the set input S is triggered. Now, let's connect these blocks. Connect the output from the less than or equal to block to the set input of an SR block. This will turn on the fill valve when the water level is too low. Connect the output from the more than or equal to block to the set input of the other SR block. This will turn on the drain valve when the water level is too high. Now, also cross-connect the outputs to the reset inputs of the opposite SR blocks. This ensures that when the fill valve SR block is on, the drain valve SR block will be off. When the drain valve SR block is on, the fill valve SR block will be off. Only one SR block will remain active at a time, preventing both the fill and drain valves from being on simultaneously. Now, let's finalize the setup by adding assign blocks from the Extras group. The assign block is used to directly assign a value to the output. Drag and drop 2 assign blocks onto the workspace. Connect the outputs of the SR blocks to the inputs of the respective assign blocks. Next, let's add a numerical constant block to provide a steady value. Drag a numerical block onto the workspace. Set its value to 10, representing the maximum signal strength for activation. Connect this numerical block to both assign blocks to ensure they receive the correct activation signal. Now, let's add the actual valve controllers to complete the system. Drag and drop the fill valve and the drainage valve onto the workspace. Connect the outputs of the assigned blocks to the respective valves. Once everything is connected, our PLC logic is now fully functional. Now, let's run the simulation and see our automated water tank system in action. If the water level drops below 2, the fill valve should activate. If the water level exceeds 8, the drain valve should activate. The logic will continuously maintain the water level between these thresholds. With this, we have successfully set up a simple water treatment system using factory I/O and control I/O. Now, let's add a simple reset switch to the entire configuration to allow manual control over the system. From the Tags group, drag a factory run block onto the workspace. Next, go to the Sources group and drag a Boolean block. Connect the bool block to the factory run block to serve as a power control switch. Now, let's turn the system on. Click on the power icon to activate the system. Press play to start the simulation and watch as our factory runs in real time. In case of an emergency stop, simply click on the power icon again. This will immediately shut down the entire system, stopping all processes. So, in this video, we learned how to set up a complete tank filling simulation in Factory I/O. We used analog sensors to measure water levels, logic blocks to automate the filling and draining process, set-reset blocks to maintain the valve states, a reset switch for manual control. This setup mimics real-world industrial automation, making it a great learning tool for PLC programming. Thanks for watching, and see you in the next video.